Hello all, this is a video for the course Basics of Matlab and I am your guru Siddharth Kaul. In this video I am going to talk about programming in Matlab. The Matlab interactive mode is very useful for simple problems, but more complex problems require a script file. In this video I have presented a very generic and efficient approach to design and development of program. The usefulness of Matlab is generally increased by the use of decision-making functions in its program. These functions enables us to write programs whose operation depend on result of calculation made by the program. These decision-making functions are also included in this video. So for design and development of any script file, the first thing that comes into mind is algorithms. An algorithm is an ordered sequence of precisely defined instructions that perform some task in a finite amount of time. So by ordered sequence I mean that the instructions that can be numbered, like first step should be this, second step should be this, third step should be this, something like that. And the algorithm often must have the ability to alter the order of its instruction, including using what is called a control structure. There are three categories of algorithmic operations. First is sequential operation, these instructions that are executed in order. Then we have conditional operation, these are the control structures that first check for a condition and then according to the condition they do instructions. Then we have third, iterative operations. So these are the control structure that repeat a certain set of instructions over and over again. So not every problem can be solved with an algorithm, and some potential algorithm solution can also fail because they might take a long amount of time to find a solution. The next component of programs design and development is structure. So every program follows a certain sort of structure. So sometimes this is called structure programming. So what is structure programming? Basically it is a technique for designing programs in which a hierarchy of modules is used. So each module will have a single entry and a single exit point. And in this the control is passed downward through the structure without unconditional branches to a higher levels of structure. These modules can be built-in or user-defined functions. An unfortunate result of the goto statement was confusing code called spaghetti code. So these were composed of complex tangle of branches, one jumping from point A to point B, then B to A, B to C, B to D, which was very hard to keep track of. So structured programming, if used properly, will result in a program that are easy to write, easy to understand, very easy to modify, and it's very much readable. The advantages of structured programming is displayed here. The first is that structured programs are easier to write because programmer can study the overall problem first and deal with the details later. Modules or function written for one application can be easily reused or modified for another application. Structured programs are easy to debug because we know where certain things are, and each module is designed to perform just one particular task. So basically these independent modules can be tested independently from other modules. Then fourth is structured program is effective in a teamwork environment because many people can work on the common program. So each person can be developing either one or more than one modules. Fifth is structured programs are easier to understand and modify, especially if meaningful names are chosen for the modules and if the documentation clearly identifies the module's task. A method for creating structured programs is a top-down design, which describes a program's intended purpose at a very high level initially and then partition the problem repeatedly into more detailed levels, one level at a time, until enough is understood about the program structure to be enable us to code it. So basically you will have one higher system level thing that will be broken down into smaller levels till it is small enough to be coded. So I have already covered the basic steps for developing a computer solution in a previous video, so I am not going into that. Now moving forwards, let's talk about structure charts and flow charts. A structured chart displays the organization of a program without showing the details of the calculation and decision processes. For example, we can create a program modules using function files that do specific and readily identifiable tasks. Large programs are usually composed of a main program that calls on the modules to do their specialized task as needed. A structure chart shows the connection between the main program and the modules. The image on the left shows a structure chart. This is an example where a game, say tic-tac-toe, is made. There is a module to allow the human player to input a move, a module to update and display the game grid, and a module that contains the computer strategy for selecting its moves. Flowcharts are useful for developing and documenting programs that contain conditional statements. This is because they can display various paths or branches that a program can take. So this depends on how the conditional statements are executed. So on the right it is shown a flowchart of if and else condition. Relational operators and logical variables. Matlab has 6 relational operators to make comparison between arrays. It has less than, greater than, less than equal to, greater than equal to, equal to and not equal to. So the example is shown here. So I am taking a vector x with elements 6, 3 and 9 and vector y with elements 14, 2 and 9. So both have 3 elements each. So I am taking z where I am putting a relational operator of x less than y. So whenever x is less than y, that element position will return 1 and rest of the element position will return 0. So as 16 is less than 14, so I will get 1 there. As 3 is not less than 2, so I will get 0, and similarly as 9 is not less than 9, so I will get a 0. Next example is of x not equal to y. So whenever x is not equal to y, it will return as 1. So again we will get first 2 elements as 1 and last element as 0. And we can also have some constant scalar, say x greater than 8. So whichever element of x is greater than 8, at that position we will return as 1 and rest of the position will be 0. Matlab has 5 logical operators which are sometimes called Boolean operators. These perform element by element operation. So we have a not operator that returns an array having the same dimension of, say, whatever the array we have, say for example not a, then it will return an array of the same dimension as a, where the new array will have ones where a is 0 and 0 where a is non-zero. Then we have AND operator. So when we say a and b, so basically this returns an array of same dimension as a and b, and the new array has ones where both a and b have non-zero elements and 0 where either a or b is 0. Then we have OR. So we say a or b that returns an array of same dimension as a and b. So this new array will have 1 where at least one element in a or b is non-zero and 0s where a and b are both 0. Then we have AND, that is short circuit AND. This is an operator for scalar logical expression. So a and b returns true if both a and b evaluated to be true, and if it false if they do not. Then we have short circuit OR. So basically again this is an operator for scalar logical operations. So when we say a or b, it returns true if either a or b both are evaluated to be true, or false if they both are not evaluated to be true. Conditional statements. So the very first conditional statement that comes into mind is an if statement. Its basic form is if followed by a logical expression, and inside that if we have statements and it is followed by AND. So every if statement must have an accompanying AND statement. The AND statement marks the end of the statements that are to be executed if the logical expression is true. A space is required between the if and the logical expression, which may be a scalar, a vector or a matrix. Let's take an example, a very simple one. Here we have an input x. We have to do square root for the same. We can add input check like if x greater than equal to 0, then and only then we do the square rooting operation. So same has been demonstrated here. We have if x greater than equal to 0, then we have output y as square root of x. In case where input x has a negative value, the program will take no action. The logical expression may also be a compound expression. The statements may be a single command or a series of commands separated by commas or semicolons or on separate lines. For example, if x and y are two inputs and have scalar values, say if x is greater than equal to 0 and if y is greater than equal to 0, then we say z as square root of x plus square root of y and w as square root of x into y. So this is like we combine two if else structures into a single if statement. The block for it is shown on the flow chart on the left. So we have two inputs, x and y. So first we are checking whether x is greater than or equal to 0. If it is false, then we will end the program. If it is true, then we will check for another y if greater than or equal to 0. If that is false, we will end the program. If it is true, then we will compute z and w as shown here. The second conditional statement is if and else statement. So when more than one action has to occur due to a result of decision, we use an if and else statement, or if and else statements. So the basic structure of use of else statement is we have if followed by the logical expression, then the statement for if, then we have else keyword, and after following that is statement for else keyword, and then we have end. Say for example, suppose that for x greater than equal to 0, we have y as square root of x, and for negative values of x and y, for negative values of x, we have y as e raised to x minus 1. The following statement will calculate y assuming that x already has a scalar value. So in the code I have done the same. I have written if x greater than equal to 0, then I write y as square root of x, otherwise y as e raised to x minus 1. The else statement can be used with else if to create a detailed decision making programs. For example, suppose for x greater than 10, we have y as log of x. For x in between 0 and 10, we have y as square root of x, and for all negative values of x, we have y as e raised to x minus 1. The statement shown here will compute the same thing y if x already has a scalar value. So the code for it is written here. So we have x greater than 10, so we have like y is log of x. So else if x greater than equal to 0, that makes the range between 0 and 10. For that we have y as square root of x, and for all the other negative values of x, we have y as e raised to x minus 1. Decision structures can be nested. They may be nested, that is, one structure can contain another structure, which in turn can contain another, and so on. So indentation are used to emphasize the statement groups associated with each end statement. So one of the important points for having a better readability in Matlab code is to have indentation for each of the group statements. So each of the control statement, whether it is a for loop, if loop, if else loop, switch case, indentation is necessary to maintain readability. Let's see about for loop. A loop is a structure that is there for repeating a calculation for a certain number of time. Each repetition of loop is a pass. Matlab uses two types of explicit loops: the for loop, when the number of passes is known ahead of time, and the while loop, when the looping process must terminate when a specified condition is satisfied, and thus the number of passes is not known in advance. So the syntax of for loop is for, then we have loop variable, we have m colon s colon n. So m is the starting point and n is the ending point, and s is the spacing between m and n. And under this for loop we have statements, and the for loop is then ended with the end keyword. So for loop can be written in a single line if statements inside the loop contains only like one statement or very small statement, like shown here. So we have for x equal to 0 to 10 with the spacing of 2, we have comma, y is equal to square root of x, and then we have used end. This whole has been done in single line. So similarly, this can also be done written in a more structured and more easily readable way, as shown in the last line, that is for k is equal to 5 to 35 with spacing of 10, we have x equal to k square. So this is more structured as compared to the previous one. However, structured one is to be preferred because it improves readability, it gives us better debugging, and it literally clarifies for us like which statement belongs to for loop and which does not. The while loop. While loop is used when looping process terminates because a specified condition is satisfied, and thus we do not have the number of passes, that is, we do not know in advance the number of passes. The syntax is shown here. So we have the while keyword followed by the logical expression, and inside the while block we have statements, which is followed by the end keyword. A very simple example of while loop is also shown. So we have x equal to 5, then we have a while with the condition of x less than 25. Inside this we have two statements. The first statement is display x, where we display the value of x,
and then we update the value of x as 2x minus 1 followed by the end keyword. So the result displayed by the display statements are 5, 9 and 17. The loop variable x is initially assigned the value of 5 and it has this value until the statement x equal to 2x minus 1 is encountered the first time. The value then changes to 9. Before each pass through the loop, x is checked to see whether its value is less than 25. If x is less than 25, then and only then the pass is made. If not, then the loop is skipped and program continues to execute whatever the statement that is following the end statement. Principal application of while loop is when we want to loop to continue as long as a certain statement is to be true. Such a task is often more difficult to do with a for loop. That is of course obvious. The typical structure of while loop is as shown on the left side. So basically we have a start where we have the logical expression. If that is true, then and only statements occur, and it will keep on occurring until this logical expression is true. When it becomes false, then it jumps to the statements that follows the end statement. Matlab first tests the truth of the logical expression. A loop variable must be included in the logical expression. For example, x is the loop variable in this statement while x less than 25 is the logical expression. So if this logical expression is true, the statements are executed. For the while loop to function properly, the following two conditions must occur. First is the loop variable must have a value before the while statement is executed. Second is the loop variable must be changed somehow by the statements. The statements are executed once during each pass using the current value of the loop variable. The looping continues until the logical expression is false. So the flowchart is also the same as the one shown here. So each while statement must be matched by an accompanying end statement. So this is the same with the for loop. The statement should be indented to improve readability, and we may nest while loops and we may nest them with other for loops or if statements. Sometimes it may happen that we may miss out certain condition, or something happens that a specified condition never meets the while loop. So in these cases the while loop goes into an infinite loop. If such kind of infinite loop occurs, we can break it by pressing Ctrl C. Break and continue statements. We can jump or skip loop iteration using these two statements. The break command, which terminates the loop but it does not stop the entire program, can be used for this purpose. For example, we have a for loop from k is equal to 1 to 10 where we have x as 50 minus k square, and we have an if condition. So if x becomes less than 0, we break it, and we have an end that ends the if loop, and then we have y is equal to square root of x, and then the end of the for loop. So when the break command is executed, it jumps to the end of the for loop as commented in the first box. However, it is usually possible to write the code to avoid using the break command. The break statement stops the execution of the loop. There can be applications where we want to continue with the iteration but we don't want to break the iteration. So we can use continue statement to do this. The continue statement passes the control to the next iteration of the for or while loop in which it appears. So it skips any remaining statements in the body of the loop. In nested loops, continue passes control to the next iteration of the for or while loop and closing it. For example, the following code uses a continue statement to avoid computing the logarithm of a negative number. So here in the second box we have x as 10, 1000, minus 10 and 100. We have y as not a number into x. Then we have a for loop with k 1 to length of x, and if we have a if we have a number in x that is less than 0, we continue. So we continue, and the statements inside the for loop is k value as k and y as log 10 of x. So the result we get here is 1204 for k, and y we get 1, 3 and n and 2. So what this happens is when the continue statement is encountered, the Matlab jumps to the next iteration of for loops and continues till the whole for loop is completed. The input is compared to each case value. If they are the same, then the statements following the case statements are executing and processing continues with any statement after the end statement. If the input expression is a string, then it is equal to the case value. A string compare returns a value of 1. Only first matching case is executed. If no match occurs, the statement following the otherwise statements are executed. However, the otherwise statement is optional. If it is absent, execution continues with the statement following the end statement if no match exists. Each case value statement must be on a single line. For example, suppose the variable angle has an integer value that represent an angle measured in degrees from north. The switch block shown on the right displays the point on the compass that corresponds to that angle. So we have a case 45 that corresponds to northeast, we have case 135 that corresponds to southeast, we have case 225 that corresponds to southwest, we have 315 that corresponds to northwest, and otherwise we say as direction unknown. Simulation is the process of building and analyzing the output of computer programs that describe the operation of an organization, process, or physical system. Such a program is called a computer model. Simulation is often used in operation research, which is the quantitative study of an organization in action. This is used to find ways to improve the functioning of the organization. Simulation enables engineers to study the past, the present, and the future actions of the organization for this purpose. Operation research techniques are useful in all engineering fields. Common examples include airline scheduling, traffic flow studies, and production lines. The Matlab logical operation and loops are excellent tools for building simulation programs. So let us see how this program structure or how this program in design and development can be applied to a simulation. So for this purpose, let's take an example of a college enrollment model. So a certain college, so the problem statement of that is shown on the slide. So a certain college wants to analyze the effect of admission and freshman retention rate on the college enrollment so that it can predict the future need for instructors and other resources. So assume that the college has estimates of the percentage of students repeating a grade or leaving school before graduating. So the first problem statement is to develop a matrix equation on which to base a simulation model that can help us analyze this problem. In this problem, we are free to assume anything. So let us suppose that the current freshman enrollment is 500 students and the college decides to admit 1000 freshmen per year from now on. The college estimates that 10% of the freshman class will repeat the year. So the number of freshmen in the following year will be 0.1 into 500 plus 1000, that will be 1050. Then it will 0.1 into 1050 plus 1000, that will be 1105, and so on. Let x1k be the number of freshmen in year k, where k is equal to 1, 2, 3, 4, 5, 6, and so on. Then in a year k plus 1, the number of freshmen is given by x1k plus 1, 0.1 x1k plus 1000. So that can be said as x1k plus 1 is equal to 10% of the previous year plus 1000 new freshmen. Because we know the number of freshmen in the first year, that is 500, we can solve this equation step by step to predict the number of freshmen in the future. Let x2 of k be the number of sophomores in year k. Suppose that 15% of the freshmen do not return and the 10% repeat freshman year. Thus 75% of the freshman class will return as sophomores. Suppose also 5% of the sophomores repeat the sophomore year and that 200 sophomores each year transfer to other school or from other school. Then in a year k plus 1, the number of sophomore will be given by x2k plus 1 as 0.75 x1k plus 0.05 x2k plus 200. To solve this equation, we need to solve the freshman equation, that is the x1k plus 1 equal to 0.1 x1k plus 1000, all at the same time. So this is very easy to do with Matlab. So before we solve these equations, let us develop the rest of the model. Let x3k and x4k be the number of juniors and seniors respectively in year k. Suppose that 5% of sophomores and juniors leave school and that 5% of the sophomore, juniors and seniors repeat the grade. Thus 90% of the sophomores and juniors return and advance in the grade. The model for juniors and seniors are x3k plus 1, that is 0.9 x2k plus 0.05 x3k, and x4k plus 1, that is 0.9 x3k plus 0.05 x4k. The last four equations, that is x1 of k, x2 of k, x3 of k, and x4 of k, can be written in matrix form as shown here. So the overall general matrix form will be xk plus 1 will be equal to A, that is a matrix, then x of k plus b. B is a smaller matrix. So xk plus 1 will be the, so xk plus 1 will be a column vector of x1k plus 1, x2k plus 1, x3k plus 1 and x4k plus 1, whereas matrix A will be the coefficient like 0.1, 0.75 as shown here, and x of k will be x1k, x2k, x3k, x4k, and the small matrix B will be 1200 and 00. Now, to study the effects of admission and transfer policies, we need to generalize this enrollment model. So let A of k be the number of new freshmen admitted in the spring of year k for the following year k plus 1, and let D of k be the number of transfers into the following year sophomore class. Then the model becomes something like this, as the equation is shown here. So we have x1k plus 1 as c11 x1k plus ak, then x2k plus 1 as c21 x1k plus c22 x2k plus dk, x3k plus 1 as c32 x2k plus c33 x3k, then x4k plus 1 as c43 x3k plus c44 x4k. So where we have written coefficient c as c11, c21, c22 and so on in symbolic rather than numerical form, so that we can change their value if we want. This model, this enrollment model, can be represented graphically by a state transition diagram. This state transition diagram is shown here. So such diagrams are widely used to represent time dependent and probabilistic processes. The arrow indicate how the model's calculation are updated for each new year. The enrollment at year k is described completely by the values of x1k, x2k, x3k and x4k. That is by the vector x of k, which is called the state vector. The elements of the state vector are the state variables. The state transition diagram shows how the new values of the state variables depend on both the previous value and the inputs, that is A of k and D of k. So the four equation can be written in the matrix form as x of k plus 1 as matrix A, x of k plus matrix B. So this A is basically a coefficient matrix that is represented as C. So we have x of k as column matrix of x1k, x2k, x3k and x4k. C is a coefficient matrix that has all the coefficient, that is c11, c21, c22 and all that, and B of k is the input, that is ak and dk. Suppose that the initial total enrollment of 1480 consists of 500 freshmen, 400 sophomores, 300 juniors and 280 seniors. The college wants to study over a 10-year period the effects of increasing admission by 100 each year and transfers by 50 each year until the total enrollment reaches 4000. Then the admission and transfers will be held constant. Thus the admission and transfer for the next 10 years are given by A of k as 900 plus 100k and D of k as 150 by 50k respectively. So these are for k values of 1, 2, 3 and so on until the college total enrollment reaches 4000. Then admission and transfers are held constant at the previous year's level. We cannot determine when this event will occur without doing a simulation. So there is a pseudocode written for it for solving this problem. So the enrollment matrix E is a 4 cross 10 matrix whose column represent the enrollment in each year. So the first step is to have the coefficient matrix C and the initial enrollment vector X. Then we need the initial admission and transfers, that is A of 1 and D of 1. Then we need to set the first column of the enrollment matrix E equal to that of X. Now we need to loop over from years 2 to 10. So if the total enrollment is less than equal to 4000, we increase the admission by 100 and transfer by 50 for each year. And if the total enrollment is greater than 4000, we hold the admission and transfers constant. We update the vector X using the formula X equal to Cx plus B. We update the enrollment matrix E by adding another column composed of X. We end the loop over years 2 to 10 and we plot the result. The script file for the same is a pretty straightforward affair. So we have a script file that is enroll1.m where we start by defining the coefficient matrix C and the initial enrollment vector X. We define the A of 1 and D of 1, that is the initial admission and transfers, as 1000 and 200 respectively. We update the enrollment matrix E with X and we start the loop for years 2 to 10. So we have for k is equal to 2 to 10, we check for the sum. If it is less than 4000, we update using the formula A of k and D of k as A of k equal to 900 plus 100k and D of k is equal to 150 plus 50k. Otherwise we hold the admission and transfer rate constant and we say A of k as A of k minus 1, D of k as D of k minus 1. So this ends this for loop. Now we need to update the enrollment matrix. For that we update b as a of k, d of k and 0 0. Now we need to calculate the new x. So this x is updated by formula cx plus b, and we update the enrollment matrix E simultaneously. This ends our for loop. Now we plot the same result and we label these. So this completes our script file. Now let us see the output. This is what our output looks like. So the point to note here is that after 4 years there are more sophomores than freshmen. The reason is that the increasing transfer rate eventually overcomes the effect of increasing admission rate. In actual practice, this program would be run many times to analyze the effect of different admission and transfer policies to examine what happens if different values are used for coefficient in the matrix C. This concludes this video on programming design and development in Matlab. So in this video we saw about conditional statement, that is if else statements, if else if branches, and switch statement, and what are the syntaxes and how they are used. Then we also saw control structures like for loop, while loop, that are used to repeat a particular set of statements. Now we also saw an example to simulation. So this is like one of the many examples that we can work on. So this is just a basic example to start with. So that is it, and thanks for watching. I'll see you in the next video.